Welcome, everyone. If you'd make sure you're muted just so we don't get background noises, that would be appreciated. We are the higher education learning community for the Greater Atlanta RCE, Regional Center of Expertise on Education for Sustainable Development. And we have the pleasure today of having our previous speaker, Lauren Whitworth from Agnes Scott College, to moderate this session with Clark Alexander from University of Georgia. If you'd like to join us in the higher education learning community, we meet once monthly, and you can find more about us at the Greater Atlanta RCE site, which I'll put in the chat. Lauren, I'm going to let you take it away.
Great. Thanks, Michael. Thanks for inviting me back. Welcome, everyone. Good afternoon on this beautiful day in the Atlanta area. So I have the pleasure of introducing Clark, who I'll then hand it over to talk with us about his topic. So Dr. Clark Alexander is the director of the University of Georgia Skidaway Institute of Oceanography and a professor in the Department of Marine Sciences at the University of Georgia, my alma mater, and actually grew up not far from Skidaway. Alexander is a coastal and marine geologist who joined the Skidaway Institute as a postdoctoral scientist in 1989 and became director in 2016. He earned bachelor's degrees in oceanography and geology from Humboldt State University in California. He went on to earn his master's and doctoral degrees in marine geology from North Carolina State University. As a researcher, Alexander has participated in 63 field programs from New Zealand to Siberia and has been the chief scientist on 29 oceanographic cruises with a total of more than 2 years at sea. He has published 101 papers in scientific journals. From 2003 to 2017, he served as the director of the Georgia Southern University Applied Coastal Research Laboratory on Skidaway Island. Alexander has been very active on state and regional advisory boards and works closely with the Georgia Department of Natural Resources to identify and address pressing coastal management needs. He served on the Georgia Coastal Marshlands Protection Committee and the Georgia Shore Protection Committee from 1998 to 2006. Alexander currently represents the Skidaway Institute to the National Association of Marine Laboratories and the Consortium for Ocean Leadership. Welcome, Clark.
Thank you very much. I've passed the first hurdle. I've remembered to unmute myself. All right, I will get this going now. Share my screens. Switch my displays. All right. Well, thank you for joining me today. What I hope to impart to you is a working knowledge of sea level rise, what's gone on in the past, what's projected for the future, kind of the impacts and implications for the Georgia coast. And we'll touch briefly at the very beginning on the importance and recognition of sea level rise and climate change as an important process for a variety of stakeholders and institutions around the nation. The first thing I'm going to ask you to do is kind of come along on this journey with me by embracing the data. There is, and I think I'm probably preaching to the choir here, but I can't tell you how many times I talk about sea level rise, about climate change, and there are people that either are unaware of the data that exists out there today to help us understand what is really going on, but also in some ways are not really willing to receive the message that there are changes occurring around the globe that we need to be cognizant of and try to ameliorate as and how we can. So first off, let's talk a little bit about that. There's a worldwide recognition that climate change is an ongoing and important threat to both global and our national communities. I just want to point out that the two major resources that are important for people to be aware of. The first is the Intergovernmental Panel on Climate Change, which just a couple of months ago released their 6th assessment report. These are international groups of scientists that get together. They decide on what we do and do not understand about how the climate system works. They build models, they incorporate agreed upon science, and every time that they do an iteration of this in their assessment reports, they come closer and closer to making more realistic predictions of climate change and its global implications. The US as well has been doing and producing new US national climate assessments since the Bush administration. And this is the 4th climate assessment that was released on Black Friday by the Trump administration. I don't want you to think that this is just a few agencies that are more focused on environmental issues. You can see in the middle of this figure all of the different departments that contribute to the national climate assessments. Department of Agriculture, Commerce, Defense, Energy, Health and Human Services, Interior, State, Transportation, EPA, NASA, NSF, the Smithsonian, and U.S. Agency for International Development. All these federal agencies and groups are engaged in contributing to the national climate assessments. So there's an ongoing concession that this is something that's important for the United States. In addition, the DoD particularly recognizes that climate change and sea level rise in particular are threats to national security, and have come out with a number of publications over the years, starting in in 2015 and going forward. And there's been a growing recognition of the threat of sea level rise, particularly to the sustainability of our operating bases for naval operations. Norfolk, one of the major ports for naval operations now, has limited accessibility during some parts of the year because of shallow coastal flooding, which we'll talk about in a little while. But the DoD sees climate change and sea level rise as a national security issue. And the Nobel Committee, you may be aware, awarded the prizes in physics this year to 3 individuals, 2 which received the award for physical modeling of Earth's climate, allowing us to quantify and reliably predict global warming. And then the other part of the prize was given for discovery of the interplay of disorder and fluctuations in natural systems, which allows us to start really quantifying the variability that is seen in natural systems, including climate. So as we talked about global warming for a moment, as we all know, the major contributor to global warming is the increase in CO2 in the atmosphere. As of the 30th, so Monday, I guess, or Tuesday, this is what the data look like at Mauna Loa, where the Scripps Institute of Oceanography has been monitoring CO2 since the late 1950s. See, do I have a pointer here? I do. So in this small inset panel, you can see this increase in CO2 in the atmosphere up to last Tuesday. We're currently at 417 parts per million CO2 in the atmosphere. We're able to go back in time over a much longer time scale by looking at gas bubbles that are trapped in ice cores. And from cores in Greenland, they're able to go back in time over the last 800,000 years, which tells us that CO2 has been between something like 200 parts per million during glacial periods and about 280 parts per million during interglacial periods such as we're in today. So over the last 800,000 years, that has been the natural trend. And today we sit up here at 417 parts per million. So the levels of CO2 that we have in the atmosphere today are unprecedented, at least over the last million years. So from a geologic standpoint, that suggests that there's something anomalous in current conditions. And that, of course, is us. If you want to look at the total global temperature anomaly here on the upper right panel, you can see starting about 1920, we started to have an increase in temperature, which is now at about 1 degree to 1.2 degrees. You can see that there are natural components to this variability. There is a solar component due to insolation and patterns with the sun. But the magnitude of that signal is 1/10 of the total global signal that we're seeing, and it's very cyclic. There's anomalies associated with volcanic eruptions, which puts aerosols into the air and which cools down the earth. But those impacts are very short-lived and are not cyclic in their nature. And also, again, the magnitude of those changes are not as large as the changes we're seeing. There is a natural variability in the system, hearkening back to that most recent Nobel Prize. And then you have the anthropogenic component calculated based on the CO2 and the warming in the atmosphere, along with other greenhouse gases, which, as you can see, contributes to most of the anomaly that we observe. And you can actually look at them in a more simple fashion here on the left and see the size of the magnitude of the human-caused climate change signal. So there are many indicators of a warming world. We don't have time to go into all of them. Today, we're going to focus on sea level rise. Sea level rise obviously occurs from the melting of on-land glaciers and ice sheets. It also occurs because of increasing heat content, which makes water expand and take up more volume. And much of the warming that has occurred in the atmosphere that heat has been taken up by the ocean, increasing the effect of the ocean expansion term over the last few decades. So why do we need to worry about sea level rise? It's because it's really flat here in Georgia. You know, a small amount of rise really translates the shoreline, say, if by about a factor of 1,000 to 2,000. So a 1 meter rise in sea level would give us a translation of the shoreline up to 1 kilometer or 2. So that's a dramatic change. And of course, you know, areas that are rocky coasts, so up in Maine, along the west coast of the US, much of that coast, that is a very steep slope. So that same meter rise does not lead to as great translations in the sea surface, the land-sea boundary. So as I say, it's very, very flat here in Georgia, and we have something on the order of around 100,000 people living within 3 feet, which is a good projection for sea level rise, good consensus number right now in the scientific community. We have about 100,000 people living within 3 feet of mean high tide. So that's a population that is going to be directly affected as sea levels rise. So as a geologist, of course, I need to start with the long view. If we look at the last 5 million years of sea level history, sea level has been fairly stable over the last 3 to 5 million years around our current sea level. But during the Pleistocene, we started to see these large glacial, interglacial cycles, which reflect ice being locked up on land and then released back into the oceans. And if we look at the last 500,000 years, you can see these cycles occur relatively regularly on about 125,000 year cycle. And this being the last cycle here shows us that about 125,000 years ago, sea level was at about its present level, but has been lower since that time up until about 20,000 years ago, and then rapidly increased. And we'll talk about what's going on today in a few moments. So we see evidence on the Georgia coast for those fluctuations, those large scale fluctuations in sea level rise by being able to map old barrier systems, which are reflected by higher elevations, sandy deposits, which are backed by muddier back barrier deposits. We see 7 barrier island chains that have formed in the last several million years, and that are reflected here. They are about 100 feet or about 30 meters higher than mean modern sea level, and they extend about 120, 130 kilometers inland, which shows you the variability that we have seen with the shoreline here along the Georgia coast. Our most modern chain of barrier islands are on the order of somewhere less than 1,000 years old and have formed since sea level regained its location after that last rise in sea level. And so if you look at a schematic here that shows you that the black islands are these young islands. In some areas, the young islands have already sort of crashed into the islands that were built about 125,000 years ago. And so you have what are called compound barriers. But in areas near sources of sediment, like the Savannah River and down here near the Altamaha River, we have a separation because of there was enough sediment to allow these young islands to maintain themselves offshore. We see separation between the old islands and the young islands. So as we discussed, 20,000 years ago, we had low sea level, about 300 feet, about 100 meters or so below modern sea level. We had rates of sea level rise during the early deglaciation period on the order of inches per year or tens of centimeters per year. And then over the last 3 or 4 or 5,000 years, we've had a slowdown in that rate of rise to a few millimeters per year or an inch per decade. And as I mentioned, that rise is from ice melting and temperature expansion of the water already in the bowl, if you want to look at it that way. What we're really interested in is what's going to go on in the future. And that's what we're going to talk about now. So when we measure sea level rise at any of these tide gauge stations that you may be familiar with around the globe, and particularly here in the US, our one tide gauge station here in Georgia is at Fort Pulaski, which is at the mouth of the Savannah River. But what we're really, because these are tide gauges that are sitting on big pilings that are driven into the riverbed, and then we look at the fluctuation of the water around that, we're really looking at relative rates of change, right? We know out in the ocean basins, sea level is rising, but as soon as you come and you start measuring it at the edge of the continents, you also are including local factors which can either add to that global rise or subtract from, depending on what the process is. So Local factors can be things like human activities. We can be pumping groundwater for municipal use. We can be extracting oil and gas, or we can be channelizing rivers, which keeps sediment from getting onto floodplains. In all of these cases, we have subsidence of the land surface. And if we have sea level going up and the land sinking, those two things add together to give us a more rapid sea level rise. There are also geologic processes. Autocompaction is where, just because you have so much sediment being dumped, say at the Mississippi River mouth, you have so much sediment being dumped with very high water content that the overburden, the pressure of that sediment continuously building up, forces the sediments and the water to be squeezed out, and you have subsidence occurring there. Active tectonics, you're all familiar with plate tectonic theory. In some areas, we've got plates moving apart. Those are very passive margins. But in some areas, you have plates coming together. One plate is overriding the other plate. And in those areas, you actually can get uplift of the land surface because of one plate coming over another plate and subduction occurring. And then there's a process called glacial rebound that I'll talk about in just a second. But what I want to point out is that you can get almost any kind of sea level curve that is possible depending on the combination of these local and global patterns. So like in Galveston, Texas, where there's a lot of sediment being dumped out of rivers, where there's a lot of extraction of oil and gas, we see a very steep profile to our sea level curve, indicating a very rapid rise in sea level. Along the East Coast, where we have relatively quiescent tectonic activity, we don't have a lot of subsidence, we see a more shallow slope to our sea level rise curves. And then in areas in high latitudes, you can actually see a fall in relative sea level because the land is moving up faster than sea level is moving up. And so when you put those together, you get a relative sea level fall. So why does that occur? That's because of glacial rebound. In high latitudes during the last glacial period, we had a large burden of ice up to 1 kilometer thick, extending for thousands of kilometers, that bore down on the crust and slowly pushed the mantle out of the way. That ice melted kind of like that on a geologic time scale. And so the crust and the mantle are still rebounding. And so land is still rising in high latitudes. And if we look at this figure from the Noaa Tides and Currents website, I'll have the website address on here later. You can see the reflection of these processes. You know, these red arrows show very rapid rise in sea level, you know, along the Gulf Coast near the Mississippi River, along the relatively more stable east and west coasts. We see rising sea levels, but at a slower rate. And once we get up into higher latitudes, which were glaciated during the last low stand in sea level, we see that sea level relative to the ocean surface is actually falling on land. And so that reflects, so what I if nothing else, take away from this talk and this section of the talk, that if someone cherry picks a sea level rise curve and says, look, sea level's falling, you guys don't know what you're talking about. It's because the people who are talking like that don't understand the combination of geologic and anthropogenic features that are going on to combine what you're measuring at your edge of the continent tide gauge station. So let's zoom into the southeast here now. These are sea level rise curves for Wilmington, North Carolina, going on down through Charleston, Georgia, Fernandina Beach, which is the next tide gauge below Georgia, and then Mayport and Miami. And basically what you see along all these sea level rise curves is a gradual increase in sea level rise at rates of 2 to 3 millimeters per year, and perhaps an increase in the rate of sea level rise, although we still need more data before we can really start saying that unequivocally. So what's going on here? These are the tide gauge records for Charleston here on the top, and for Fort Pulaski, the one Noaa tide gauge station in Georgia. And so we've got 85 years of record here in Georgia for Fort Pulaski. Here's the daily data basically, and you can see when we regress through that data, we've got a rate of sea level rise of 3.4 millimeters per year, or about a foot per century at the current time. And we see something similar up in Charleston. So over the record that we see, we've seen a continual rise in sea level. So you can't argue that sea levels are not rising based on this data. We also know that sea levels are rising globally because what we really want to do is see how sea levels are rising away from the edges of the continent, so we don't have to deal with these geologic and human factors that can affect the sea level rise that we're measuring. And so starting in the early 1990s, the US and now other nations around the world have put up satellites that circle the globe, measuring the distance between the satellite's well-known orbit and the surface of the ocean. And you can see the data, the overlapping data from the first satellite we put up, Topex Poseidon, Jason 1 in red, Jason 2 in green, and Jason 3 in purple. And these missions are still occurring today. If you regress that data, you get a rate of sea level rise out in the open ocean of about 3 millimeters per year, which is fairly close to what we're seeing in Charleston and what we're seeing at Fort Pulaski, suggesting that there's not a large contribution from active tectonics or subsidence or those kinds of processes in the Southeast right now. So what are the predictions? So if we sort of slap this all together, we have geologic proxy records that we didn't talk about today, but which exist. We have our tide gauge records, the earliest start around 1870s here and around the world. We have our overlapping satellite data, which will be continuing into the future. And then we have predictions and models, which give us ranges of outcomes depending on how we respond to our carbon footprint and other greenhouse gases that we're putting out into the atmosphere, and how we respond to pushes for carbon-free energy versus a more carbon-rich energy source. These envelopes kind of show the high and the low range. The assessment 6 report that just came out from the IPCC suggests that their consensus values are something up and around 3 feet or about a meter by the end of the century, down to about 1.5 feet or half a meter by the end of the century. This number down here assumes that there will be significant decreases almost immediately in terms of the output of greenhouse gases, which I think we've seen from the last global climate meeting that's just been over last month, that's not going to happen. So we're operating somewhere within this territory, and this is reasonable with some cuts to emissions, but not wholesale cuts, and not business as usual. Business as usual is up here, and as you can see here, the new assessment report is starting to project out different scenarios, and they have about 2 meters to 8 meters by 2300, depending on how we respond in the coming centuries to this question of climate change. Now, I do want to point out that these are models that are being used, but every time the IPCC has gotten together, they only include in their modeling things that all the scientists agree they understand how to model. So the first assessment report included only the atmospheric models, land surface feedbacks, and ocean and sea ice. The second assessment started incorporating aerosols. The third assessment included the carbon cycle and dynamic vegetation growing and dying off globally. And then the fifth assessment included land ice, and they're still working on cloud dynamics and ice sheet behavior, because those are not yet factored into these models. So I like this saying, all models are wrong, but some are useful. And that's exactly the way to think about the assessment reports coming out of the IPCC, that they are being conservative in their estimates. So when they estimate 1.5 to 3 feet of sea level rise, you know that those are conservative. They're not including all the processes yet, because we don't understand all of the major processes, but the modeling is being conservative in the estimates that they are putting out. I mentioned earlier that the federal government is taking climate change and sea level rise very seriously. Both the Army Corps of Engineers and Noaa have their own sea level rise models now that federal agencies are supposed to use for planning for sea level rise when they're doing projects. And so this Noaa intermediate high value, which shows a rise of 6 feet by the end of the century, is what a number of municipalities are starting to use, and Noaa is using as a target sea level rise when doing planning. So this kind of 3.3 feet target level, again, is very conservative, like I mentioned that the IPCC does. And the alternatives and the options going forward will probably be higher. I do want to point out that we're still finding out about processes that are known but not widely known. And most recently, many of you may have read in the papers about the 18.6-year lunar nodal cycle, which is basically the moon has an ascending and descending mode in its orbit, and it's around the ecliptic plane as it goes around the Earth. Sea level is rising, and as the moon goes through this cycle, it has a higher gravitational impact and a lower gravitational impact on sea level rise and what the tides look like. So as sea level is rising in the background, right now, the lunar cycle is on a downward trend. So this is what the tidal cycle looks like with superimposed on the increase in sea level rise. So right now, we're not really seeing the full effect of rising seas, because the effect and the impact of the moon is decreasing and will decrease until it starts on its upward phase. So around 2030, that's when we will start to really see enhanced impacts of sea level rise that's going on in the background right now. So there are actually, target dates that you can start thinking about when we'll start seeing the impacts of sea level rise more impactful to the coastal zone than we are seeing it now. And so that can kind of disguise the impacts. I do want to mention that there is a hyperlocal sea level rise monitoring program that Georgia Tech has been implementing over the last couple of years. Everywhere you see a circle here, they have a sea level rise sensor, which is monitoring sea level rise. You can see down here in the bottom the daily, the twice daily water level variations at one of their sites. And this data is going to be collected and used to help to make very hyper local predictions of flooding and tidal inundation. And this will be being expanded throughout the Georgia coast relatively soon to help make better predictions for tidal inundation and flooding. So I want to briefly touch on major consequences of sea level rise, because I mean, if you live up in Atlanta, it's not going to impact you. But if you like to go to the beach, if you have a second home down on St. Simon's Island or things like that, you're going to start seeing impacts when you come down here. The first impact is more frequent flooding. As you can imagine, if you have mean high tide now at a certain level and sea level is rising, your mean high tide level is rising. And so over time, you expect to see more and more tidal flooding. This is predicted days of flooding at Fort Pulaski, which means that the road out to Tybee Island gets flooded and is not passable for some part of the day. And you can see with increasing sea level rise, whether with lower emissions or higher emissions, as sea level rises, we can predict that we will be seeing, well, by the end of the century, we'll be seeing 350 days of flooding each year, which means that at least one of the two tidal cycles, high tides a day, will be inundating the road out to Tybee Island unless something is done to adapt to that. And you can kind of see the real data here showing that increase in inundation of that road. So more frequent flooding of transportation infrastructure and other kinds of properties adjacent to water. Second, more frequent storm inundation. Obviously, if you have no water on your property during a storm now, but your base level for where a storm comes is going up because sea level is going up, you're going to start seeing inundation of your property. Here's a onshore wind pushing the tides up over our bulkhead at Skidaway back in October. You can see our bulkhead right along here. So those sorts of things are going to be more common. Saltwater intrusion, as sea level rises along the boundary of the land marsh or land water boundary, you have intrusion of that salt water getting into the groundwater. You can see that on a small scale here. Obviously these trees used to live on a small marsh island that was high enough above the marsh as to not be inundated. Those trees weren't planted dead, let's put it that way. So that this used to be a habitat where plants that needed fresh or brackish water could thrive. Now the groundwater is intruded with salt water and they no longer can thrive. This also is a great indication that shows you that sea levels are rising because the marsh has grown up to and onto these small islands that we see all over in the marsh in Georgia. Also, less efficient stormwater and septic systems. As sea levels rise, at high tide, you have water going up into your stormwater systems. So there's less capacity to hold rainwater if you have a rain event during high tide. And we see that in the city of Savannah. And then, of course, as sea levels rise, groundwater levels rise. And so you are decreasing the amount of distance to treat your septic tank effluent before that effluent reaches the groundwater. And so the septic systems, which are very common in coastal Georgia, become less efficient. And then, of course, we have erosion and migration of the shoreline. There are a number of different responses. Here's the director's house for Skidaway Institute, private helicopter, you know, all those things. I'm just joking. Sorry. But you know, moving shorelines, you can armor them in some way. You can put in structures and renourish beaches. This is what a natural system would look like, right? You can see the salt marsh out there in the distance. Here's the brackish marsh plants growing up into the forest, which is on the marsh upland boundary. So a marsh wants to migrate onto the upland to keep itself in relation to the intertidal zone as sea levels rise. So briefly, we have responses to eroding shorelines. You can either do hard armoring, fixed engineering, soft stabilization, which is becoming much more common in this day and age. That's beach renourishment, living shorelines, those sorts of green infrastructure. And then there's relocation and retreat, which has not been a very popular option up to now. So hard armoring, here's just a few examples that we saw in a few moments. That's like bulkheads, that's like rock revetments. There's a seawall that runs along the front side of Tybee Island all the way up the island here. And then you can see the seawall in this image of the south end of Tybee Island from 1976. So these are all structures that want to keep the shore in place. The problem with that is, as we discussed earlier, salt marshes and other plants that live in the intertidal zone want to migrate onto the upland as sea levels rise, right? You want to stay in that intertidal zone. So as the intertidal zone moves up with sea level rise, you move landward onto the upland and maintain the marsh. When you start armoring the shoreline, you experience something called coastal squeeze, where you start to lose your intertidal habitats. You know, we've got rock revetments here, we've got seawalls, we've got bulkheads. And in this instance, as sea level rises, the plants and the marshes migrate landward to stay within the intertidal zone. But at some point, they can't migrate any further landward. The tidal range gets too high and they're drowned too frequently. And so you lose those kinds of intertidal habitats, which I think most people are aware. These are very important habitats, both as nursery grounds for commercial and recreational important species. They are important for storm protection. The marsh grasses knock down a lot of wave energy. They detain floodwaters. They suck up contaminants on particles. So they serve a lot of functions that are important for the state. Renourishment is a more common option now. So here's Tybee Beach before renourishment. You can see structures exposed in the shore face. And here's Tybee Beach after renourishment, much broader. And we've pushed the shoreline back out to protect upland infrastructure. And then Cape Hatteras Lighthouse is one of the few examples of retreat that has been done in the recent past. That was done in 1999. You can see the original location of the lighthouse. It did originally have 2 baseball fields between it and the water, but shoreline erosion had started to threaten it. And so it had been constructed so it could be picked up, put on a platform, and then moved inland as necessary. That was 11 million of your taxpayer dollars did that. And then lastly, I just want to mention a few tools for visualizing coastal change. One is the Georgia Coastal Hazards Portal. The address is here. And it has, it's designed basically to allow you to look at your own vulnerability if you live on the coast in association with assessments of shoreline change, the location of flood and storm inundation zones, looking at historic shorelines, as you're seeing here from maps from 1933, 1970, and 2000. So you can see how dynamic the coastline has been over time. The other tool that I would like to point out is the NOAA Digital Coast Sea Level Rise Viewer, which is a really great tool if you're interested in flooding on the coast. It's very graphic, it's easy to understand, and you're able to move sea level up by 1 foot increments for any coastal area. This is showing 6 feet of sea level rise and what areas will be inundated. If you're familiar with Skidaway Island, we're located on the north end of the island, and some of our property will be underwater, and the central part of Skidaway Island will be flooded as well at high tides. The green areas are areas that would be flooded, except that they are there's a barrier protecting it from inundation. So this is a great tool, and you can use it to look at things like this. Current mean high water on Tybee Island right now. You can see the marsh back behind here, areas that would be flooded if they weren't protected. 3 feet of sea level rise, showing areas on the island, particularly this very low-lying area in the back southern end of the island under 3 feet of sea level rise, and then what Tybee Island would look like under 6 feet of sea level rise. And we're actually, myself and some other faculty from UGA and the city of Tybee are working on a National Fish and Wildlife Foundation grant to try to find ways to address this vulnerability on the back side of the island, where it is not as obvious as how you protect it. The front side of the island, you can just renourish the beach and you build dunes and you keep water from inundating the front side of the island. However, the low-lying backside is another issue, and we're looking for good solutions to that question. And then lastly, I do want to say, although with sea level rise, our marshes seem to be doomed, but there is research that's been recently published looking at the distribution of elevations of marshes in Georgia. And you can see that this black line is mean high water. Much of our marsh in Georgia sits right at about the mean high water line. So it's very high in the intertidal zone. Other marshes, if you were looking at this same plot for marshes up in Virginia, they would be sitting down here much closer to mean sea level and be much more threatened by sea level rise. But modeling using this distribution of where our marshes are today suggests that our marshes are going to be pretty stable through the end of the century because they have a lot of what's called elevation capital right now. So they can withstand a lot of sea level rise before they start to become fragmented and drowned. So that's a good thing. And that's the end of what I wanted to talk with you about today, and I'd be happy to answer any questions. I guess I should stop sharing.
Thanks so much, Clark, for a really rich, very rich presentation. And I appreciate that you ended on a positive note in otherwise fairly dire news. So for folks who, probably everyone's familiar with Zoom at this point, but if you're not, you click on reactions and you'll see a raise hand button, and we will call on you to ask your question. Feel free to jump in. James.
Thank you for a great presentation. I really learned a great deal and appreciate you organizing it so well. What do you think about the recent fourth highest tide on Tybee and the road closures?
What do I think about it? I think it's a sign of things to come. As you know, that was a perigean astronomical high tide. You know, moon was closest to the earth. It was predicted to be higher than normal. And we had some onshore wind. So whenever you have onshore wind, it piles up the water even higher than the tides are predicted to be. And so I won't say it was unexpected to people down here, because we pay attention. Noaa comes out with a quarterly assessment. These are the days when the tides are going to be highest and when we predict that there's the strongest chance of flooding. But I do think it's a sign of things to come, because basically, today's highest of the high tides are going to be tomorrow's average high tides. And so, well, the thing about the road out to Tybee, it's interesting, that had been flooding very, very frequently, and the DOT came through and resurfaced the road, adding up to 8 inches of macadam in some areas to get some elevation on that road. And the number of flooding events has gone down dramatically, but they haven't ceased. And so they bought some time for those kinds of events and those kinds of denial of access to the island, but they haven't stopped them. Bruce?
Clark, thank you so much. This was really a very, very informative presentation. And we hear a lot about these issues, but we don't get a lot of precision in the discussions that we often hear. So I'm very interested in how the kinds of projections you were discussing play out in the urban areas of Georgia. I wonder if you could comment about what this looks like in Savannah and Brunswick, and other significant towns along the coast, and any thoughts you have about how those cities might respond to those challenges.
Mm-hmm. Definitely. So well, let's talk about Brunswick first. They actually have started experiencing a lot of issues with flooding during spring high tide events. And so I'm not as familiar with how they're trying to address that. I'll speak more about City of Savannah and Chatham County because I'm much more familiar, and City of Tybee Island. So Chatham County and City of Savannah have been very proactive about trying to integrate sea level rise and the impacts to the built infrastructure into their planning. If you're familiar with the Savannah area at all, we have the Casey Canal, which is a very broad canal that most of the stormwater drainage feeds into for Midtown Savannah and much of downtown as well. That canal, because of sea level rise, was being so full and water was going so far up into the piping systems. You got to remember that when a lot of the City of Savannah original storm drain system was built, it was built 100 years ago for a sea level that's a foot lower than it is today, particularly the downtown systems. And so the volume and capacity of those systems during high tide was greatly diminished and greatly decreased. So what the city and the county have done is they've built stations along the Casey Canal where they have these sliding doors that if they know there's a large rain event predicted, they will wait till low tide. They'll close those sliding doors so they can now maintain all the capacity within the canal for receiving those upland storm drain discharges. So that's been very proactive. City of Tybee, they did a sea level rise adaptation plan in 2016, and there were a number of low-hanging fruit kinds of things identified. One was to elevate your pumps for your well, so you can both still pump fresh water, but also keep your well heads above where they might get water intruding into them if there are sewage laden waters during a flood, say from a hurricane. You really don't want your wells to get contaminated, and you want to be able to use them over time. So they've elevated all their well pumps and well heads all over the island. They've also, one simple solution to water intruding up your drainage systems, if you don't have the kind of capacity and canals to take water and things like that, is to put flap gates, basically just rubber flaps that close when the tide is high. And then when the tide is low and there's water in the system, the water pressure forces them open and lets the water come out, but they stay shut when because of the water pressure when the tide is up. So that allows you to keep your storm drain capacity unaffected. And that's a kind of a very easy adaptation that can be done. So there are a number of things going on. And as I mentioned, this people living on the edge of the marsh is the biggest problem for both Georgia coastal counties, no matter whether they're urban or rural, really, because there are no good ways to, unless you build up some sort of a barrier to keep the water off of the upland. And you can't just do it in isolation because water just comes in around the sides. And so there's a lot of work going on right now trying to understand nature-based features, things like living shorelines, vegetated berms, on the upland, things that both provide habitat, wildlife corridors, but also provide protection or freeboard, if you will, for high water events. But then the question becomes, what are you going to plan for? Because nobody wants something 8 feet high, and a Category 3 storm probably has, a 8 to 12 foot storm surge, and you can't really protect against that in a reasonable way. Did that answer your question?
And that's very helpful. Thank you. I'm gathering from what you're saying that the 2100 projections for Savannah don't look like a large portion of the city would be underwater. Am I getting that right?
Yeah. Oglethorpe, the guy that founded Savannah, was no fool. He chose the highest piece of land around, and so Savannah is between 30 and 40 feet high, located on what's basically a gigantic sand dune complex that was built at the mouth of the Savannah River, probably somewhere between 500,000 and 125,000 years ago. So they located the city itself in just the right kind of place to give it resilience to those kind of flooding events.
So if folks will allow me, I'm going to ask one follow-up. And this may be an unfair question because you're a coastal geologist, and this is really more of a policy question. But are we going to treat this as a public problem or as a private problem? When I look at what we did with Katrina in New Orleans, it seems to me that we largely left people to their own devices, and the public sector didn't take responsibility for the largest share of it. But the public sector did a lot, but not nearly enough to make New Orleans whole with respect to that storm and the future prospects. What do you see as the issue or the likelihood that we treat this as a public problem or as a private problem?
That's a really good question. And I don't think I can address it comprehensively by any means, but I think that the reality of the situation is that there is only going to be so much funding available. It would probably take trillions of dollars to, if not more, to address the low-lying, vulnerable populations that we have all throughout the low country, the southeastern US. And you can imagine that centers of industry, Savannah might be lucky because we have a major port. Charleston may be lucky because they have a major port. New York is a major center for business and industry and port activity. And, I think that the federal resources are not limitless. And even now on Tybee, I showed you that low-lying area on the south end of the island. I don't want to guess, but there are a good number of homes that are eligible for being elevated. If the cost could be brought down to where people could actually afford to do it. And FEMA will provide funds as they're able to certain numbers of homeowners, but the number of homes that they can accommodate with every allocation from Congress is much smaller than the demand. And I'm sure it's a similar thing throughout the country.
Oh, thank you very much.
David, jump in and then back to you, James.
What an engaging talk. Thank you so much, Clark. I was wondering, actually, let me give some context first. I do a lot of work for Nevada coastal areas like South Florida and New York City. And just 10 years ago, they weren't talking about retreat. And now planners in cities like New York City and Miami, it's at the forefront of a lot of the conversations that we're having. I'm wondering, what does the discourse look like in coastal Georgia around retreat? Are they having that discussion? Is it still taboo? And if they are, what does it look like? Are they taking it seriously? You showed us a lot of examples where, whether it's green or gray or some hybrid, adaptation isn't going to be enough. And so I'm wondering, where's the state of the conversation right now among practitioners?
I will say I haven't necessarily been at the table with all those discussions, but I have not in the groups that I've been involved with, I have not seen any significant movement on the retreat issue currently.
Thanks.
Mm-hmm. Yeah, one of the issues that arises is that pretty much, as you're probably aware, is there isn't a lot of places to retreat to without leaving that contiguous location near the water that people are so justifiably fond of.
James.
So quick question. I was on Wassaw Island the other day and we went to the highest peak and I was told that's the highest peak in Savannah. Is that true?
I can't say for sure. I know that the very high sand dune there was actually formed during a hurricane in late 1800s. I can't remember right now. I'm not sure that it's as high as the highest elevations in the city of Savannah. I want to say it's somewhere between 25 and 30 feet though.
Yeah, it was a very tall dune. So
was that on the road directly across
on
from
the Pavilion Trail
property?
So there's a trail called Pavilion Trail, I think.
Mm-hmm.
Robert.
Hey, can you hear me okay? Okay, thanks. Forgive me not turning on the video. Dr. Clark, that was a great presentation. Thanks so much. What I would love to get a sense from you about, if you can, you've talked about the actions of the cities as entities, the cities of Savannah and Tybee Island, and their efforts and how you've been working with them. I wonder what you would have to say about the attitudes of the residents of those cities to this happening, to the changes that might have to be made in the cities. I lived in Savannah for several years. I know Tybee very well. There's frankly a lot of conservatism in those cities, despite the sort of liberal bent that urban areas tend to have in the U.S. So I wonder if you can say anything about that. And thanks again.
I can honestly say that there is a broad spectrum of opinions. I have talked to residents on Tybee, those that are staying no matter what, and those that wish there were alternatives, and those that are in between and would like to find ways to adapt to what's coming so that they can stay where they are, but are realistic about the long-term prospect to be able to maintain the kind of lifestyle that they have now. I think that it kind of reflects where we are as a country, that there is a very broad range of opinions about what's reasonable, what's not reasonable, what's possible. And I think everyone is very aspirational in their hopes about whether they can just do what they're doing now, or that they can find some way to leverage technology or engineering to maintain their status quo. But I think it's all over the place. But there are people who understand that, well, I may be able to live here until I have to go to a retirement home, but my kids may not be able to be here. You know, and a lot of people that I talk to here that live very low in the tidal frame, like I'm 9 feet above sea level, you know, at my house. And a lot of us are having the conversation about, well, pretty soon I want to move before my house's value starts to go down. So there's a very raw economic interest to get out before it's too late. And a lot of people see their flood insurance starting to go up as well. There are new changes to the way Fema calculates your flood insurance rates that will include the distance to a body of water, which was, it always was just based on elevation previously, but now it includes distance to body of water, which is going to change a lot of people's flood insurance rates.
My parents are on St. Simons and ran into that very thing following the hurricanes. I think it was Matthew that flooded their garage, and I'm not even sure that the bottom floor can be insured. Yeah, Michael, I think I saw you next.
Actually, can I just say one more thing? The federal flood insurance, it only goes up to $250,000. So it doesn't matter how much your house is worth. It only is going to provide some relief, you know, and so there's another trade-off in your thinking about whether it's worth it or not. So I think that there's a lot of things converging that are going to be making people think about their situation in the future. Sorry, I didn't mean to cut whoever was next off.
Oh, that's fine. Thank you. So this is an extension of the public opinion question, but this has to do with the organizations that are seeking to address this issue. And so the Georgia Conservancy, for instance, has been working on this issue for over a decade, at least, maybe even longer. I'm wondering if there are other organizations that have become active around this, local within the coastal zone. How are people organizing to address this issue other than by trying to influence government?
And when you say this issue, are you talking about sea level rise in particular?
Yes.
Or?
Yes, and the response needed by communities to address that.
Mm-hmm. Yeah, there are a number of NGOs that are trying to address this. One that I'll mention is 100 Miles, which does try to function within the legislative space and try to influence government and policy. The Georgia Conservancy you mentioned, the Nature Conservancy is doing some work, although they're much more focused on preserving existing wildlands here in Georgia. That's really their thrust in my experience. Other organizations now, Emory has the Georgia Climate Project, which is a very large initiative, which is bringing in a number of different universities. I know UGA is very active in that space as well. And then, you know, there's a lot of interest on the part of academics who are engaged on the coast from both a social science and a physical science standpoint. And so, you know, like this group today, we try to educate everyone who's interested so that there's a broader understanding so that better decisions can be made in the future. And we interface with the management agencies as well. We have a good ongoing dialogue with the Georgia DNR and the Coastal Resources Division, because they're kind of the point of the spear for the state with these issues. They have a coastal resilience specialist. They have a hazard specialist. They have a grant program that targets questions that they need answered to better manage the coast. And then there are efforts that are a little bit more pragmatic, that are being led by Brian Bledsoe at UGA. There's a Engineering with Nature initiative within the Corps of Engineers, and he's just recently established the Network for Engineering with Nature, which is a collaboration between the Corps of Engineers and academic engineers and other folks dealing in the climate and coastal space to try to both help the Corps do their job, but also to help the environment while the Corps is doing what it sees as its mission, which is, you know, to keep ports and channels and the intercoastal waterway open, but still need to dispose of that material. But if they can do it in a way that's beneficial to the environment, you know, it's a win all the way around. So we're trying to, people are engaging on a number of different levels and a number of different ways, from the, you know, political, legislative, academic, even sort of applied sides.
So to follow up on what you just said, I was actually involved with the state of Louisiana. They had sued the Environmental Protection Agency over the fact that the Army Corps of Engineers was not doing any beneficial use of dredge materials and the resulting loss of wetlands. You seem to suggest that in fact this situation has changed. I don't know if considerably, but has it? How effective is that reuse process? Do they in fact move significant amounts of dredge materials into beneficial use, or is it kind of marginal?
Well, I would have to say that it really depends on what Corps of Engineers district you're talking about. The Mobile district has been very active in this arena for quite some time. The Savannah district and Georgia just started their beneficial use stakeholders group. The first meeting was October 26th. And so I'm part of that stakeholders group, but there is an interest in pushing this kind of technology and this kind of methodology forward, you know, with Georgia DNR getting together with the academic community, getting together with the Corps of Engineers, and finding where these technologies can be used. I would say that it's in its infancy in Georgia in the Savannah district, but there is definitely a push from Corps National, DOD, to take this kind of thing seriously. It isn't just lip service, I don't believe, from everything I've heard.
Thank you so much. I think that's going to be the last question that we have time for. Thank you for a fantastic presentation and a wonderful discussion following it. Clearly generated some great discussion. So round of applause again for Clark, and I'll hand the mic over to you, Michael, in case there's anything else you wanted to add before we all sign off.
Thank you, Lauren. No, thank you very much, Clark. That was a very engaging conversation, and the Q&A was fantastic. Thank you all for joining us.
Sure. Thank you very much. I appreciated the time and I had fun.